In this lesson and the next lesson, we're going to look at how to combine forces. Before we do that, we need to remind ourselves the difference between what we call a scalar quantity and a vector quantity. Okay, so a scalar quantity is a quantity that just involves one bit of information in order to describe it. That's the magnitude or size of the quantity, whereas a vector quantity is a quantity that involves two pieces of information. The first bit of information is its magnitude, and the second is its direction. Okay, so scalar quantities, just magnitude; vector quantities, magnitude and direction. So let's just have a quick look at some examples of scalar quantities, some of which you'll be very familiar with. So for example, we have mass, distance or length, time, speed, temperature and energy. They're all examples of scalar quantities. Whereas examples of vector quantities are forces, or force, which is what we're looking in this unit, change in position or displacement, velocity, which is a measure of how position changes with time, acceleration, which is a measure of how velocity changes with time, and since velocity is a vector quantity, then acceleration is also a vector quantity, and then momentum, which is the velocity multiplied by the mass of an object, which would also therefore be a vector quantity. Now, we'll look at momentum, acceleration, velocity and change in position later on when we look at motion along with speed. But in this unit, we're looking at forces. So we're interested in how do we combine forces. So when we're communicating information about a scalar quantity, then we only require, as I just mentioned, just one bit of information, and that is the magnitude of the quantity. Now, that makes combining scalar quantities quite easy, and you've been doing that ever since you were in primary school. So for example, if you have 10 grams of a substance in one beaker and you add it to 10 grams of the same substance in another beaker, then all you've got to do is sum the magnitudes of the quantities to get the total mass of the substance in the beaker. Likewise, for example, you might say last month Anne was 152 centimeters tall, and then since then she grew 5 centimeters, so her height now is 152 plus 5 is 157 centimeters. So it's just a question of adding the magnitudes. I'm not wanting to insult your intelligence, I'm just pointing out that combining scalars is quite an easy thing to do. Now, when communicating information about scalar quantities, this is relatively simple because it involves just one piece of information. When we're communicating information about vector quantities, this is slightly trickier because two bits of information are needed, the magnitude and the direction. So for example, to describe a force, we need to say something like this. We need to say, for example, the force is 10 newtons in an upward direction, or 10 newtons up, or 20 newtons northwest. Or we can simply represent the force using an arrow. And an arrow is a very useful device because it contains both magnitude, which is represented by the length of the arrow, and obviously direction, which is the direction that the arrow is pointing in. So it's very common to represent forces or vector forces using an arrow. Now then, again, as we mentioned, whereas combining scalar quantities is relatively easy, combining forces, which are vector quantities, is more complicated because you've got to deal with two bits of information. That's to say the magnitude and the direction. But the good news is that in most of the problems that you come across, the forces acting on a body are going to be either in the vertical direction or in the horizontal direction. And so when we're combining force vectors in this situation, we need to remember the positive and negative notation. So for example, in the vertical direction, the down arrow is negative, the downward direction is negative, whereas the vertical direction is always positive. Whereas in the horizontal direction, the arrow to the right is always positive and the arrow to the left is always negative. So for example, if you have a situation where a number of forces are acting on a body, as in the case of this car, then what you'll need to do is, first of all, to determine the resultant force of the forces acting in the vertical direction first. And in this case, the resultant force will be equal to, well, you have a reactive force of 10,000 newtons pushing in the upward direction, which is balancing the 10,000 newtons weight of the car acting in the opposite direction, acting downwards, which is the negative direction. So to find the resultant force in the vertical direction, we take the 10,000 newtons upwards minus the 10,000 newtons due to the weight, which is equal to 0 newtons. So we have the forces in the vertical direction will cancel out. So most of the problems you come across in your GCSE physics, the forces in either the vertical or the horizontal directions, one of the two, will cancel out to make life easier for you. And then we need to determine the resultant force in the horizontal direction. In this case, we have 1200 newtons thrust produced by the engine. That's a positive force acting to the right. And then we have 600 newtons as a result of the air resistance and friction between the road and the tyres and the moving parts of the car. So you've got a combined force there of all the frictional forces of 600 newtons. They're acting to the left. That's a negative force. Okay, and so summing the forces in the horizontal direction, we have 1200 forces thrust minus 600 frictional force, giving us a resultant force of 600 newtons acting to the right. Now, the fact that, even though I haven't put a plus sign there, implicit in the fact that it's positive means that the force is acting to the right. So although it might not look like that, we have actually included the direction of the force here in the horizontal direction. Because it's positive, it means it's acting to the right. Now, you might get a different situation, for example, where the car is braking. Now, and in this case, the frictional forces plus the force exerted by the brake is now greater than the thrust of the car, and so that's going to cause the car to slow down. And in this case, the forces acting in the vertical direction both cancel out. That's the weight and the reactive force and the reaction, whereas now the forces acting in the horizontal direction, well, we still have a 1200 newton force acting to the right, but we have a force acting to the left of minus 2000. So the sum of those forces are 1200 minus 2000, which gives us minus 800 newtons. Now, this minus sign now means acting to the left. That tells you the direction the force is acting in. So we don't necessarily need to say it's 800 newtons acting to the left, although you can do. All right. So as an answer, that would be fine. If you were to say this is 800 newtons acting to the left, that is exactly the same as saying it's a force of minus 800 newtons in the horizontal direction. Likewise, if you say here that this is 600 newtons acting to the right, that is exactly the same as saying it's a positive force of 600 newtons in the horizontal direction. Now, in the next lesson, we're going to look at slightly more complicated situations where we have forces that are not acting in horizontal or vertical directions. And, these tend to be for questions that are in the sort of 8 to 9 category in your GCSEs. Okay, so we'll have a look at those in the next lesson.